Okay, so I'm going to show you how to set these things up and do a few in Excel. One is just going to take you through like an example of each of the 4 types of problems in your practice homework. The first thing I want you to do is, of course, when you're doing these, you should be doing them in Excel, and what you should do for all of these, right, because basically you're just going to use Excel like a calculator for these. I want you to take and put in those variables that I showed you from the previous page. So I'm going to take mine that I already had and just copy them over here. Whoa, that's big. Yeah, that works. All right. And then what you can do, like if you're trying to make like a data entry kind of situation, you know, it's not a bad thing to like make it look nice, right? So you can, what I like to do with these kind of things is give it the all borders on the inside, and then take and re-highlight it and give it a heavy outside border. Okay, and remember we said that the payment for these is always going to be 0, and the type is always going to be 0. So remember, there were 4 variables in all of these equations that we could solve for, right? So we might want to know the future value or the present value, and then we also might want to know how long it takes to get to a certain goal. Or we also might want to know what the interest rate is given a certain set of parameters. And all of these situations are quite realistic. They apply to your normal financial life as a consumer, as an investor, as, you know, just a human being in our economy. And so for all of these, like I said, I want you to have a data entry screen, and then down here you can just, you know, do the function here, right? Okay, so what do I mean by that? Here we have problem 3-2. Dixie Bank offers a certificate of deposit with an option to select your own investment period. A certificate of deposit is a product that banks sell, which is basically it's a savings product, but it's not quite as easily accessible as your regular savings account. So if you get a CD, right, you can't get the money back out of that CD for 3 months, 6 months, 3 years, etc. So here we have Dixie Bank offers a certificate of deposit with an option to select your own investment period. Jonathan has $10,000 that he could invest in this. If the bank is offering a 4.5% interest rate compounded annually, how much will the CD be worth at maturity if Jonathan picks these various investment periods? Right, so we want to know what's the future value at 4.5%. And then our number of periods is going to change. But let's start with 3 years. The payment is 0. The future value is what we want to solve for. So we'll just leave that blank for now. And the present value is $10,000. Now I want to note something, and you might have picked up on this when you were looking at the textbook to go along with the last lecture. In order to do these problems, your present value and your future value in Excel kind of need to be opposite signs. So if you want to have a positive cash flow as a result of an investment, you need to indicate the investment as a negative number. You're taking money, you're taking it out of your hands and you're putting it into the bank's hands, and then after it grows at 4.5% for 3 years, it's going to come back to you as a positive cash flow. So we're going to say our present value is a negative $10,000, right? And so the question is, what is the future value? Okay, so we invoke the function with the equal sign, FV, and it's going to prompt us for all of these arguments. So we just take them right down the column here. The rate, 3 years, the payment 0, The future value we don't know. The type is 0. I'm sorry, the payment, it's looking for the payment next. And then the type is 0. It should give us, come on, 11,411. Right, so that's how much our investment is going to be worth in 3 years at 4.5%. Now, the magic happens, right? So you would put that in here. And I guess they want it to the nearest cent, which I find annoying because it's ridiculous with numbers these large, but let's do it. So we put in 11,411.66, hit enter, and it's correct. So now, haha, watch this. All you got to do is change the number of periods to, what's the second one, 5? Boom. It gives you the answer. Okay, 12,461.82. Okay, so that's how you do these future value problems. Okay, so I'm not going to solve all the rest of those out for you. Let's just look for the next one. That's a different, yes, we want to leave this question. Okay, so this is future value again, so I'll leave that to you. Present value. So now this one is interesting, and the thing is, like I keep saying, these functions in Excel, solving them out is trivial, right? It's figuring out how the heck to set the things up that's the hard part, right? But these are kind of realistic examples. When they're first born, Grandma gives each of her grandchildren a $4,000 savings bond that matures in 18 years. So what that means, a savings bond is a very, very safe investment in vehicle. Grandmas tend to like these kinds of things. And so you purchase something when a baby is born at something less than $4,000, and at maturity, right, when the child turns 18, that thing will be worth $4,000. So the question is, okay, the first thing I'm going to hit here is how much do you have to spend on them for a newborn, right? So let's see, this is 5.5% discount rate, and it's 18 years, right? So when the child is first born, again, the payment's going to be 0. The future value now we know is 4,000, type is 0, and the present value is what we're solving for. So we invoke the present value function. Here's our rate. Here's our number of periods. Our payment is 0. The future value is positive 4,000. The type is 0. And we want to solve for the present value. Hit enter, and that says that she needed to spend, right? It returns as a negative cash flow. So when a baby is born, she would spend $1,500 to purchase a bond that will mature in 18 years at a value of $4,000. Right, but that's not what the question is asking. Well, it's asking that for letter E here, right? Again, the tricky part is not setting up the function. The tricky part is figuring out how to attack these problems, right? So let's look at the question again. When they're first born, Grandma gives each of her grandchildren a $4,000 savings bond that matures in 18 years. For each of the following grandchildren, what is the present value of each savings bond if the current discount rate is 5.5? So Shane, our baby, his present value is $1,525 because he's got 18 whole years for this thing to mature. But Seth turns 16, so he's only got 2 more years for this thing to mature. So let's see what's the present value of an investment that's going to be worth $4,000 2 years hence. Right, and so it recalculated for us. 3593.81, and let's just check it and make sure that that's right. So that's how you go about that. I've said it before, I'll say it again, I know I'm being repetitious. The hard part is figuring out what the puzzle actually is that you're trying to solve. Okay, and the puzzle here is how many more years do we have left for that thing? what is the number of periods that we need to use to solve our present value problem. Okay, so that's how you do the present value problems. I'm going to zero this out again. Okay, so the next thing, which I didn't really address during my sort of concept overview, is calculating back for the interest rate. Now, this is actually something, it kind of, the way that they've got it set it up here, it feels like this really academic thing, but in reality, it is not uncommon for the interest rate to be undefined in a business deal. I was working as a business advisor when a startup brewery I was working with was doing equipment financing, and they needed to buy the tanks, and the tank vendor offered them financing because for startup businesses it's very hard to get bank loans. So the equipment vendor offered them financing, and again, they did not explicitly say what the interest rate was, and so I tried to help them figure it out, and I'm like, my God, it looks like that's like a 30% interest rate. That can't be right. But you know what? It was. Okay, so interest rates are often hidden in deals, and if you're not financially sophisticated, you know, you might not realize how much interest you're paying. So that's why they have you, in this book, solve for interest rates. Now, Excel has a function called rate, but let's just look at this first example. So we invest $350, so we're going to call that a negative $350 for our present value. And then the future value, oops, sorry about that. The future value is $769.78, and the time period is 9 years. Payment 0, type 0. Okay, so what we need to do is we invoke Excel's rate function. So the number of periods is 9. Payment is 0. Present value negative $350. Future value $769. The type is 0. And they're asking you for a guess. The way that Excel is going to solve this problem, because if you recall the algebra, the number of periods was the exponent. And so Excel does this through an iterative process. It just goes round and round and round. I think it will do it without us having to provide a guess, but we will see situations where we need to use a guess when we're figuring out a rate later on in this finance class. So it's 9%. Right, so that's a 9% rate of return. That's incorrect. Okay, I am going to leave that mistake in there because I want to show you how I fixed it. Okay, so, you know, I saw, wow, that's incorrect. That's weird. So I paused the video and I figured out what the problem was, but I probably should have left the video running while I showed you the process of figuring out what the problem was. So the first thing that I did was look more closely at what I had entered for my data entry. And if I go backwards here, right, I had entered a minor typo here, 769.48. It should have been 78. Okay, but then the other thing was that it's looking for me to round to 2 decimal places. So if I increase the decimals, it's 9.15%, which when I entered it, and in fact was correct. Okay, so when they say round, do what they say. Okay, so that is how you solve these figuring out the interest rate problems. So there's another example of that. I like this example a lot. I will talk you through it, but I'm not going to solve you through it because again, the rate question is trivial. You know, you just solve the thing in Excel. So two mutual fund managers are arguing over who has the highest performance. And I guess I just want to tell you that a mutual fund is a type of investment where it's like a bundle of different securities, bundle of stocks and bonds and various different investment options, all within one product that is sold by fund managers. A really, really well-known and well-regarded fund management company is Fidelity down in Boston. And so we've got the situation where they want to know who is actually getting the best return on their funds. And so Martha's mutual fund, she was selling 11 years ago for $28, and now those shares, if you wanted to buy one today, it would be worth $62. And so the question is there, what's the rate of growth? What's the effective interest? Again, I don't like using interest in this because, this isn't just interest that is causing these funds to grow. It's the growth and value of the stocks as well. And then David said investors bought shares in his mutual fund 5 years ago for only $3.50, and they're now worth $7.40. And so you're trying to compare a rate of growth across different time periods, right? So what you would do to solve this is you just do them separately, kind of note what the different rates of return are for each of those managers, and then pick from this multiple choice which one is the best. Okay, so that's another interest rate question. And so now we have looked at future value, present value, we've looked at interest, and then the last variable we want to look at is waiting period. So Jamal wants to be a millionaire, don't we all? Okay. And so we want to know, so now we're solving for the NPER, right, the number of periods. And let's see, so the first question is if he invests at 19%, which is a ridiculous rate of return, and the question of the number of periods, that's what we're solving for. The payment is 0. The future value is $1 million. Sometimes when that comes up, it just means that you don't have enough room in your column. Okay, what that means is 1 raised to the exponent of 6, which is, I believe, $1 million. Let's just double check with the commas, make sure I have it right. Yep. Okay, the type is 0. And then the present value is, again, if we want a positive future value, we have to have a negative present value. So our investment now is 23,328.56. Okay, so now, again, Excel has a function for number of periods. Right, so our rate and payment is 0. Present value is what they want next, and future value and type. And for whatever reason, it gave me in percentages, which I don't want, 21.6 years. And we are looking for a whole number here, so let's see if we get that one right. Yep. Okay. So, people, those are the 4 types of problems. Now I'm going to end this here, and you can go ahead and practice before you sit down and do the graded assignment.